So today we are talking about data quality frameworks. And how do you spell your name?
It's P-A-L with the circle above the A. So it's
That's Paul.
But it's Paul, like in English, Paul, right? So that's
Paul. Okay.
Yeah.
And
so that's
Devib. That's
Deviba.
Deviba.
Yeah.
Okay. Great. So that's who we have here today. First lesson learned. Okay. So I will give you the stage, and in the end, we will have some more dialogue and questions and answers.
Great.
And go ahead. Thank you.
Yeah, let's see if I can manage to share the screen. That's the first challenge for these days. Yeah, you can see my screen now, right?
Yes.
Right. So I just want to say that I think it's a super nice initiative. And it's very nice that we have this cooperation across countries, because I think there's so much to learn from sharing knowledge and experiences in these sort of bleeding edge technology domains, right? So thanks for a very good initiative there.
Great, and let's hope we can build this together to share and learn from each other, tackling the same problems.
Definitely. So I'll talk about data quality frameworks. I have worked with it somewhat, but I'm not sort of a top expert in it. So I'm very open to feedback or suggestions or corrections while I'm talking. So if that means interrupting me with your voice because I don't notice your hand, then that's fine. So just let me know. Yes. So there's a quote on urban planning which says growth is inevitable and desirable, but destruction of community character is not. The question is not whether your part of the world is going to change. The question is how. And I mean, here we are this is in Rio in Brazil, and there's sort of a mixture of organized and disorganized. And this is very typical for our domain. And there's a lot of innovation, a lot of quick growth. And then we try to keep some kind of order also, right? And then how do we deal with that? And data quality frameworks is part of that, both in getting quality, but also how do we make them play nicely together with our platforms. So, I mean, here we have a city which is Dubrovnik in Croatia, a very beautifully organized city. It was so well built, the outer walls, that it was actually never conquered, as far as I understand. And you see it has a port, it has streets, it has efficient security. And in this sense, we can see that an architecture is not just one thing, it's multiple functions. And it's also always a creative process and an experience-based process to try and build a platform or data way of working in an organized way. You can hear my voice nicely, right?
Yes.
Yeah, great. And I mean, here is a street market. Can't remember exactly the country, but I mean, this is also trying to solve the needs of the participants in the community, but it's a little bit more maybe like our data platform sometimes, right? We have a lot of needs, a lot of functions, often competing for space. And I mean, today I'll talk about some of the first, as a frame, the desirable qualities of data work, sort of which to plan for, as a context for how to select the data quality framework. Point two, I'm not talking about that. That's sort of a leftover for from a previous talk. But I'll talk about data quality frameworks, and I'll go into some of the frameworks specifically, right? And then try to give a conclusion at the end. So what are these qualities of data work that we want to plan for? I mean, we want to plan for certain qualities and have design principles or methodologies in those plans so that our data platform and our data pipelines essentially can be sustainable and give value. So prevent chaos, prescribe conventions, and educate users by the power of example. And I mean, some of these principles then is sort of sustainability, enabling cooperation, knowledge sharing, for example, with a monorepo, or with a wiki, or other ways. Autonomy, people should be able to do their job without depending on sort of a very technical data engineer. Security and access control, you should be helped to do things in the correct way. So it shouldn't have to be something that blocks your data production. With privacy, it's a little bit of the same. I mean, it can't be solved sort of once for all, but it should be possible to make it easier, for example, with synthetic data with services like tonic.ai. And then very important is the data worker user experience. That could be a data engineer, data scientist, or an analyst. And to have sort of the user, the real user, at center stage. So don't build a data platform which only works for extremely technical developers if that's not what you're dealing with. And this user experience should make it possible to access and obtain data, know where exploratory code goes, not only production code, but where can I put and version my exploratory code and exploratory data elements. So normally, I mean, often what happens is that if Paul starts making a table with exploratory data, or then I will make Paul _1_ customers, for example. And it's better to have a convention, for example, prefix with the branch name you're working on or the issue ID you're working on, so that by default you have a way of working that is not only for production but also for the exploratory process. And these conventions should be also for branch names and how to commit code, should be easy to share code across projects and departments, easy to deploy code to automation or production, which is sort of the same thing, and should be easy to use data quality checks. Also should be possible to test run data pipelines, not just the individual steps of the data transformations, but actually the whole pipeline. And very important is the thing about having access to production data where it's permitted, so that you analyze either real production data, masked production data, or synthetic data inspired by production data. And then the data quality checks, it's not just about, should we do it or not? It's about how to make it easy to incorporate that into the way of working. And there's a quote here from an article from about the use of great expectations at the Norwegian public company called Statnett, which manages the electric grid. And they say that just like defective physical assets, data pipelines can break also, and the consequences can be huge. And those consequences are bigger and bigger the more we become data-driven. So high-quality data is necessary. I'll share the slides later so you can look into the articles. So what are the desired features of data quality frameworks then? I mean, it's should be simple to use. It should be, you should have a pedagogical way of working so that you have examples which helps you to do it in the right way. An example there could be DBT, which is a sort of data engineering framework, which makes it very easy to split up your data pipelines into separate files in the right way. So even if that's not data quality, it's an example of a pedagogical way of working which has enabled a lot of data engineering and analytics. I mean, the data quality frameworks can have different expressiveness. How do they support Git versioning? Are they compute engine agnostic? Can you use them on Snowflake or Databricks or BigQuery, etc.? Are they performant? Do they act as a team player in the data platform? Is it open source? Does it have good APIs? What is the sort of underlying assumptions of the framework that makes it easy or hard to integrate into data platform? Can it do data quality across rows, not just to say, is this null or not, but sort of averages or outliers across a column. Does it have profiling and data drift detection? How does it have a way of, sort of a default way of handling failing data? Can it quarantine data? Does it fail hard? Can you do it? Can you customize it? Or do you need to build that yourself? Is there solid backing by a community and a company? I mean, is it a living framework or is it a dying framework? Which is extremely important when you take these sort of urbanism long-term architecture decisions, because you don't want to be based on a dying framework 3 years down the line. And in this sense, sort of also, is the design sustainable? Is it a well-designed API and overall interface? For example, you could say that Pandas has proven to be a very powerful interface to interact with data. So that is then an example of a well-designed framework. And is there some or a lot of support for data pipeline operations? Sort of how do you stick this into your data pipeline setup on your data platform? Also, just a disclaimer is that LLMs are arriving fast and wide. There's a lot of use cases for LLMs and other parts of AI. And so here you have 2 examples. On the left here, you have the Databricks agent, which is sort of a natural language interface with your private data lake, basically. So you can ask questions in human language about your data. And on the right side, you have a similar open source framework doing a similar function over Pandas data frame using OpenAI or some other LLM. So this is an example of how fast this thing is changing. LLMs might not be the best case for data quality checks because you need a numerical understanding and you need precision. And I couldn't actually find a brute force nicely integratable profiling tool protecting against data drift. There's one I'll talk about a bit later, but there's still things to happening here. And I think in the world of data governance, though, auto governance, there we definitely have room for LLMs, sort of auto document this column name, etc., etc. And as for example, in Databricks, this is already integrated. So there's going to happen a lot of stuff here, which will democratize analytics. So let's start with the framework. I'll start with Great Expectations because it's sort of the standard somehow, most well-known framework. It's mature, it's powerful. It is based a lot on the command line, but it's quite opinionated, and it assumes a lot of things about your way of working. For example, it assumes that you are in a command line, you have a local file system, a browser, and you can spawn notebooks in your browser. And this makes it sometimes not trivial to integrate with Databricks or BigQuery Studio or some hosted notebook setup. And I think part of it is that it is very sort of tailored out of the way of working in reality of a data scientist. So you're on your machine, you have some data, you want to start working with it, and you run some commands. But this the fact that it's so opinionated can make it hard to integrate. And you do have a lot of functionality. You have profiling, notebook integration, extensive library of predefined expectations. You can customize expectations are specific sort of no values in this column, or the average should be between this or that, or we should not have any missing values here. Or they should all be valid emails. So there's an extensive library, so it's very expressive. It supports a lot of compute engines, including Snowflake, Databricks, SQL in general, Pandas, and they have a cloud service launched, which I think is called GX something. It's on the internet. It seems similar to how DBT is. They have DBT Core and then DBT Cloud. Seems like they're going for some of the same thing. Here you see the user interface of the profiling. Now, the challenge can often be sort of how to get the validations into Git. How do you get them versioned? How do you display validations inline? This is from the documentation of Great Expectations for Databricks. And you see here it says, because you use the DBF file system for your Datadog store, you need to download them locally to view them. So here you see that opinionated local desktop way of working sort of coming at odds with Databricks way of working, or BigQuery way of working. And in reality, there's a lot of people saying that using Great Expectations in a production setting can be challenging. That is okay. Okay, let's see here. Yeah, just trying to get up all the Teams dialogue in case there's some questions or something. And if we then go to the evaluation of Great Expectations, I mean, this is my estimation, partly from trying to integrate Great Expectations into Databricks, the data platform at Telia in Norway. And I mean, it's powerful. The instant feedback helps to refine and add checks for data. You get a sample of the data that makes the expectation fail. It is not limited to data frames. It has support for a lot of different engines, but it seems heavy, and even the naming is suboptimal. So it's called Great Expectations, which makes it very hard to Google. And for me, that's sometimes an indication of sort of, okay, who designed this? Did they think about that? Why didn't they find a Google-able name? And for example, checkpoints is one of the key terms in the Great Expectation framework, and it's not very clear what those are before you read up on it. So bad naming can be an indication of bad design, and there are a lot of complaints on the internet about it when you actually try to integrate it into data ops, into your pipelines. And the expectations are stored as JSON instead of code. So you produce them with Python code, but they are stored as JSON. And this dichotomy sometimes becomes a bit difficult to handle when you start building bigger suites of expectations. Yeah, so it's important to know about because it's sort of a primary candidate coming up. Now, another very normal candidate is DBT. Okay, just are there any questions on Great Expectations before I continue? Okay, I'll continue. Let me know if there are any. So DBT is a very popular data engineering or analytics engineering framework. It's very well designed. It's a hybrid way of working, making it Git-centric from the get-go, which I think is sort of key to its success. And this here is not about DBT itself, but it's about DBT built in data quality checks. And I mean, DBT is extremely popular to use together with Snowflake. I believe the Norwegian pension fund uses it, NBIM, or the so-called oil fund. I know Oda, a big sort of virtual supermarket company, uses it. So it's become extremely popular, used in 70% of major companies in the world, if I remember the number correctly. And it has sort of built-in, it has three built-in test types: singular sort of SQL condition statements, which you can see here, down here, which is sort of assert total payment amount is positive. So you sum the amount of all payments, and you make sure that it's positive. by convention, this assert name and putting it under tests, as far as I understand, will make this an assertion on your data pipeline. So it's a very sort of opinionated and easy to use way of doing a data check. And there's no installation here. This is part of DBT itself. Also, you have generic sort of unique not null tests, which you can add on your columns. And you have generic, which is sort of generic tests, which are SQL statements turned into these generic statements. So it's sort of a reusable singular statement. I use generic both words here, but I know they're singular, generic, and custom. So the custom ones are SQLs that can then be made into sort of generic functions. So it's quite expressive, not as expressive as Great Expectations, but you can incorporate Great Expectations with this package DBT expectations. So here we can actually say expect table row count to equal other table. So sort of across tables. Expect column values to be of type number. Expect this minimum value, maximum value. So there's or quantile values. So here it becomes very expressive, and since and it seems to be pretty widespread the use of the DBT expectations, making it somewhat a safe choice. It is safe to assume that it will be here in the future. These tests exist in DBT because they are useful. They add a lot of value. So data quality, it means data quality itself is useful, and it means that they have been proven to be useful in the framework. It's already integrated, very easy to start and use, and it has a lot of expressive power. Now, if you're not on DBT, the question is it worth it to bring in DBT to have it? Maybe not. I mean, there's some issues with virtualization, which makes DBT not perform as well on huge amounts of data in certain cases. And how do you bridge these tests if you're in a non-DBT setting? Let's say you want to validate a Kafka stream event. Also, I mean, are we abusing the Jinja or sort of YAML syntax here? Is this actually a programming problem that should be solved in Python? Yeah, that's sort of an open question. You can, of course, make plugins, but sometimes directly having them in Python can be better, or it can be worse, depending on if you're dealing with SQL data engineers or Python data engineers. Delta Live Tables is a Databricks technology, partly inspired by DBT. It's a little bit quirky because it's serverless compute. It has notebooks and streaming data. So this is another alternative for another framework for data quality. There's already support for expectations in the framework, and both Python and SQL is supported. It's expressive. It's already part of the data pipeline, and it's part of the UX also. So you can actually get the data quarantined, and you get the visualization. You can get alerts, etc. So it's not only part of the engineering, it's part of the data ops experience also. Now, DLT is a little bit quirky. I'm not fully convinced that DLT will be the dominant data engineering tool in Databricks in the future. It's a little bit quirky. It could merge with normal notebooks. And another thing is that the notebooks are growing a bit too long often when you do sort of many steps of data engineering. So where DBT has a very intelligent design of sort of nudging you to have one transformation in each step, DLT has many transformations. The other question is then, why can't I use my expectations in my regular Spark notebooks? So often then what you could do is you do your regular notebook as a part of a Databricks job, and at the end you do a pure DLT job, which does the expectations. So that's one way of dealing with that. In any case, if you're not a Databricks, this is not an alternative. It's not open source yet, might be in the future. Now, Soda. Soda is a very popular choice. I hear a lot of good things about it. It's open source. It's sort of mixed open source, a little bit like DBT. It offers a web service over the cloud, and it has a fairly sort of complete open source functionality. I think it's called Solar Core. It has a lot of preset checks available. It integrates well with a lot of compute engines and frameworks. It's a Python lib, so it's probably easy to extend. And there's explicit functionality to handle scans and pipeline ops. So it is thought out to be more integrated into the data. And I mean, here we have an example of Slack warnings being triggered. And there's UX if you have the paid version. You see this, the format is also YAML, so it is similar to some of the other frameworks in that sense. In general, there's a lot of positive experiences with it, but I read one evaluation saying that firing queries to database is not a way to do data quality at scale. So I cannot sort of vouch for how it scales in huge contexts. And the other worry is that the open source version will become a bit incomplete, and they will kind of move data profiling in these aspects out of the free version. Apart from that, every time if you're in a big company, getting approval for bringing in a new third-party service is not always easy. It's much easier if you're on Azure to use Azure Databricks because it's part of Azure, and use DLT data quality checks because it's part of Databricks. It's much harder to say we want to use DBT Cloud also, or we want to use Solar Cloud also. Then you have compliance, you have procurement, you have these processes that can take months or sometimes almost years. Pandera is another competitor. It's pure open source, and it's sort of specifically designed to be data science ML first, should be close to data science tools and conventions. It has been designed in a way of working which enables gradually introducing data quality to a project without sort of adopting the whole stack, like, for example, Great Expectations or DBT, you could say even. Customization rules should be simple, seamless integration with existing tools, and zero configuration. You don't need to set up a lot of YAML and TOML files that you might have to do with Great Expectations. It's part of Union.ai open source tools for data science, which is sort of a stack, which it has decided to become a part of. In general, I like that it has an intentional design philosophy, building on experiences on how to do this. You see, it's Python, so it's easier to compose than a YAML-based format. But it's Python, so it's harder to use if you're not a Python programmer. So that's a pro and con depending on how you see it. Yeah, you see the syntax here. Good familiar API. The good part is a familiar API based on schema checking that makes the library easy to get started with. You see, it's fairly similar to normal. It's sort of schema based, which is a very simple way to understand this. These are my expectations for a data set. It has support for hypothesis testing on the columns, data profiling, and recommendations of checks that could be relevant. So it has sort of a intelligent profiling part of the framework. Not so good, few checks included from the get-go. Messages sometimes not very informative if the check is done through Lambda functions. Apparently only works with Spark, however, Pandas, but Spark now has compatibility with Pandas, so maybe you can use with Spark also. The question, and it seems like there's no, or there might be no way to test for properties, sort of the metrics, distribution, average, etc., or the size of a data frame across different runs. That's I'm not sure if that's covered by the profiling or not. In general, I'm positive, but it's still not a very big player, so it is a bit of a risky bet in that sense, in terms of the long-term sustainability of this option. Now Pydeequ is the Python version of Deequ, which is an Amazon data quality framework. The idea is to create unit tests for data. I guess that's the idea for most of these frameworks somehow, or at least it's been said often, but that's the sales line anyway. You can calculate metrics through analyzers and assertions based on those metrics, compare metrics across different runs, assertions on data drift. So it's a framework that has been used for a long time in data pipeline, data ops, data engineering, and it's definitely mature. It's made by Amazon. There's solid performance, solid engineering, but it used to not be Python. Now it is Python, which makes it a very competitive choice. It's expressive both for sort of metrics, these sort of overall profiling checks on the whole data set, but also on specific columns. And it has a very clear integration with CI/CD. So here you have, you see, you do check results as a data frames, you get the results, and you can interact with that. There's also AWS Glue managed service is now getting it. I think it has gotten Deequ support now. So if you want to do that as a managed service, not sure if Pydeequ is supported, Deequ is. But in any case, this is fully open source. Yeah, you see here's a profiler. You're doing here's a data profiling, and you can see completeness, compliance, correlation, mean on different columns. So that's sort of a integrated, solid, and mature part of the framework. You can use PySpark to parallelize otherwise expensive checks. So you can split them up across clusters, throw them against EMR or Databricks or similar. Support for external metric repositories, data profiling, constraint suggestions. You can actually get suggestions on what constraints you want to have. It's not a pure Python project. It's a wrapper around Scala Spark. The code might not look Pythonic. Only makes sense to use if you're already using a Spark cluster, maybe. I mean, you can run Spark locally, which is possible, even in a GitHub action or CI/CD step. Yeah, but it now has strong Spark 3 has strong Panda support, so you can integrate much better with other frameworks than you could previously. Why data profiling? It was previously known as Pandas profiling. So this is another alternative. It's more focused on profiling itself. Primary goal is to be a one-line exploratory data analysis experience like Pandas df describe function. So it's sort of an easy way to get a profile of a data set. And you can also manage alerts. Here we have example of alerts. So this is more on the profiling side than the sort of schema checking side. There's a lot of, it's integrated with notebooks, and you see integration with Databricks seems straightforward. Should be the same with Colab or BigQuery Studio. And the profiling is sophisticated. And I mean, this could be combined with the other frameworks. So it doesn't have to be either or. Looks solid. Support for both Spark and Pandas. Focus on profiling. You can compare data sets, which is very important. Yesterday's function or a reference data set version, and compare it to today's version of a data set. Yeah, not so good. Alerts are not really well articulated nor accessible through code. Transitioning to partially closed source, it seems like it's sort of also going for a DBT cloud kind of strategy, and it seems like it might not share all that source as open source. Gut feeling on my part there, but it could be an issue. It's not a fully expressive data quality framework, but maybe you can combine with some of the simpler frameworks. And maybe it's a good idea to split profiling from simpler data quality sort of schema checks anyway. Now, Pydantic with validations. Pydantic is actually a schema framework for Python, very popular for Python APIs. It's you can integrate it into Fast API or other frameworks, and it's solid, it's mature, and you can kind of extend it into doing some validations also. It's widely used, so it's a safe bet in that sense. And it's designed to be fast and efficient and small. So here you see you have an email and you define it as the type email string, which makes it check that it's an email string. It's very easy to use in different kinds of contexts because it's not opinionated about where you apply it. Not so good. Few built-in validators, no built-in support for metrics validation, sort of completeness, correlation, etc. Nor profiling. Now, this is the next framework is the only data drift ML-centered framework we'll look at. This framework is specifically looking at data or model drift. So you check two versions of a data set and see if the aspects of the data are changing. It has notebook dashboards, so it's easy to integrate with Databricks or BigQuery, etc. It has data profiling, and it has data drift reports. So here you see you can actually run a data drift, focus on a single column or multiple columns, and you have a reference data set and you have a current data set, and you compare them and you get a report about drift. So this is to data drift is typically when you train a model with a certain kind of data, let's say before the COVID pandemic, training on transport data, and then the model works nice until the pandemic hits, and then the data is totally different. So the model starts behaving totally different also, even exponentially different. And to protect against that, we need to protect against data drift. So then one way of doing it is applying this kind of technology to see that your code, that your data is not changing its character and thus making the model invalid. I looked at a few of these. The interface seems very good here. Nice notebook examples that I could run without any problems directly in Google Colab. So that indicates a user centricity in the design. Powerful data drift detection. Data ops integration must be built manually. I didn't see sort of any API or functionality for integrating into data ops. And it must be combined with the standard data quality framework for simpler checks. Some other candidates, Monte Carlo, LLM, data auto governance framework that are coming, YLogs, Metaplane, Databand, and other model and data drift ML frameworks. Monte Carlo is getting a lot of positive feedback. And I know Colibra is also launching, has also launched a data quality framework recently. So I cannot say how those compare, but I mention them here. Now, so the conclusion then for me, I think I would start with Pydeequ. If you want to do data drift protection, maybe with Evidently, or just use what's in DQ, the profiling there. For me, it seems simple to use, pedagogical way of working, easy to integrate, a team player in the data platform, and it's solid and it's performant. But if you are already with DBT, or you already have access to a data quality framework, then it might be better to just go for that. So a conclusion for a sort of sustainable development plan for your data platform. The consequences of poor planning or lack of planning will manifest over time, and it becomes increasingly difficult to change. A lot of people, I read a couple of reports about people having implemented great expectation and it really becoming a pain and hard to change typical technical debt situation later. If you, on the other hand, design well, you can have
sorry to interrupt. Just,
yeah.
Does anyone in the call have an experience of Monte Carlo? It's not a framework itself, it's an application, but is there any notes of that?
Very interested in hearing if somebody has experience there.
It's kind of like a Mercedes-Benz of data quality monitoring, and of course the sales is good on them, but I don't know about the reality, so would be nice to hear. But if nobody has heard about it, so we don't have any facts.
Yeah, it's definitely a blind spot. If so, anyone, please raise your voice. I did not look into it, but I do have heard good things about it.